I'm going to present a project that is ongoing in Kaunas University of Technology since late 22. It's called SmartWins. It's about boosting our research capacities in Kaunas for conducting research in the field of built environment and digital twins. And as you can realize, the acronym of the project is from the word smart and from the word twins, from digital twins, so SmartWins or Smart Twins, or you can name it as you wish. The main idea of my presentation today is to demonstrate a project which concerns a twinning concept. The twinning concept is a concept that has been developed and proposed by the European Commission for the so-called widening countries. The widening countries are those countries in the EU, those EU member states that are considered not to perform very well in terms of research. So in terms of their metrics, these are those countries that have less budget in research, that have less research projects, and we have 17 widening countries. Lithuania is one of them. And the main idea of the widening projects and of the twinning projects is to assist, to support these countries, these member states, to improve their research performance by establishing collaboration with esteemed institutes from other member states which have better performance in research, the so-called non-widening countries. So this is overall the concept of the widening calls. And in our case, we discuss and we present this twinning project, which is based on digital twins for buildings. And actually, our research group is mainly in Kaunas, is mainly involved in the field of smart built environment, sustainable built environment. And our consortium in the case of this project consists of partners across Europe. So it's Kaunas in Lithuania, it's the Polimi, the Politecnico Milano, it's Contact, a spin-off of the Technical University of Berlin, it's CERT from Greece, the ITI Institute, which is based in Greece, and a partner from France for dissemination purposes in Innotrop. And the main idea of this project is to support Kaunas to improve its performance, its research performance in the field of digital twin technologies and in general for the digitization of the assessment of the built environment, the sustainability of the built environment in the fields of energy, smartness, and of course for concerning environmental aspects. Now, this is the main concept of the twinning projects presented in this slide. So the twinning projects, as explained, they are aimed to, let's say, link widening countries, so research institutes in widening countries with top-class leading counterparts across EU member states with the purpose to transfer knowledge. So the main idea of our project is that we wish to receive knowledge from established institutes across Europe for the field of digital twins. And a bit more specific on the twinning projects, twinning is not on the widening projects. Twinning are not the only projects that we have under this, let's say, group of calls. We also have the teaming projects, which they aim to establish research institutes across widening countries with budgets of 25 or 30 million euros. Usually it's each teaming project. We have the ERA chairs, is another form of widening calls. And we have the cost actions, which are under the widening costs. And in general, the main idea of the widening costs, of the widening calls, has been elaborated. Now, our project in a nutshell, you can see this infograph that includes all the essence of what we will conduct or what we are implementing in terms of SmartWins. We have four, let's say, main clusters of activities. The first one, work package one, is related to research activities, and this is the topic that I will focus today in my presentation. So I will mainly present the research activities that have been implemented by now in SmartWins project. Something which is important to mention is that by definition, the widening projects are not research projects. So there is a limitation of 30% of the total budget for research activities. So in other words, we are not doing research, it's a coordination action. We are focusing on the other activities that are demonstrated in this slide as well. So we are focusing in training. You can see we have a work package which has different training activities, including summer schools, the development of curricula for digital twins, training sessions, interaction among the partners for training for digital twins. We also have a work package which concerns linkage with business. So under this work package, we organize brokerage events for digital twins, citizens events, where we demonstrate and we disseminate developments in the field of digital twins and buildings in Lithuania in order to get the input of the society, of the market, and to consider that for developing further research activities. And of course, we have a work package to improve the way we manage research, so for research management. And as said, the partners are shown in the slide. KTU is the leading partner, and we have partners across Europe, Polimi, CERT, Contact, and Innotrop that support this activity. So in terms of our research, and this is where I will focus and I will demonstrate some of the results that we have. We are, let's say, performing research in 4 fields. The first one is in the field of life cycle assessment, that is digitizing life cycle assessment and developing digital twin principles for conducting LCA. And I will demonstrate what we have achieved the past few months. The second one is in the field of indoor environmental quality. So we aim to develop our practices and to advance our practices in conducting IQ studies under controlled environment with our environmental chamber in KTU. We want to digitize the whole procedure and create digital twins infrastructure for this purpose. Also, the third task of the research component of the project concerns data management, IoT, digital twins for assessing the performance of smart buildings. We have some work there which is also going to be demonstrated. And the fourth task is a beam to BEP. So we do a lot of energy performance simulation of buildings in Kaunas. We want to align this with the BIM environment to integrate our practices and retrieve all the information that we need from IFC files. We will also discuss what we have achieved in that field. I will not go into detail for the other, let's say, work packages that I have here. The only, let's say, thing that I will keep from work package 2, and that is how we improve our research management, is task 2.2. So in terms of SmartWins, we have the budget and we aim to organize a major event in Lithuania, a conference. And in collaboration and in communication with ED and BDTA, we aim to host the next BDTA conference in spring 25 in Kaunas. And this will be presented by Professor Jure Leonis right after this presentation. So he will present some details for the upcoming conference for 25 for digital twins. It will be hosted in Kaunas, Lithuania, in Kaunas University of Technology. So this is in terms of this project, the SmartWins project that it is presented right now. And as said, activities for linking with the market and the business, and training activities, which I will not analyze in this presentation. Now, what concerns our research component, we said that we mainly have 4 tasks, focusing the first one in LCA and digital twins, the second one in IEQ and digital twins, the third one in IoT, big data management. You can also see the leading partners in those. It's Polimi, CERT, and it's also Contact for the BIM to BEP, let's say, task. What we have achieved by now. Concerning the digital twins and the LCA, we were able, during this past 20 months, to develop a tool that performs LCA from BIM. That is a tool that can analyze information of the building from IFC files and IFC parser, that collects all the information that we need in order to analyze the performance of the sustainability performance of a building. We have also developed a data set of EPDs, that is environmental product declarations, and we have developed a tool that may conduct LCA from BIM files. And this has already been announced in a publication of late 23. And we have also used this tool in order to conduct the LCA assessment of typical geometries of buildings across Europe. So we have exploited some studies of BPIE concerning the EU building stock, how the buildings are developed and delivered across the European continent. We have developed typical geometries across Europe, and we have conducted, using this practice, that is a BIM to LCA practice, the LCA of different buildings across Europe, and this is also to be published in Energy Journal. It is expected. It's in the last stages of its publication, this study. Also, in terms of our work, we have conducted a detailed review assessment of the existing studies concerning geometric parameters and digital twins for assessing buildings. And we have published a study on that, so a literature review on geometric parameters to update digital twins in building assets. This study was published in the Journal of Building Engineering. This is also in terms of the project. It was one of the first steps that we did, and it compiles all the current developments in the relevant field. We have also done some work which concerns the assessment of the urban traffic, and with some predictive models in terms of assessing sustainable transportation in the built environment, which was also done under the SmartWins project, in the sense of post-processing big data and using predictive models and machine learning towards extracting some, let's say, predictions on the performance of different, let's say, information that is related to the sustainable built environment. And this is also a study that was recently published in Smart Cities Journal. Other relevant work that was developed based on the SmartWins project concerns the development of smart operational rating. This is another study that was published last year by the group, by the same people conducting the Smart Twins project. It concerns the performance of the operational rating of buildings with digital twin models, that is, with BIM models. And we see here the rationale of this approach. So we start with the physical asset. We convert that into a virtual model. We extract the information that we need from energy meters, and we are able to extract the required KPIs in order to develop the operational assessment of the building. At this point, it's important to mention that our group in Kaunas has also initiated, and it's currently coordinating, a working group under TC371. That is a technical committee for the energy performance of buildings. And this working group is working towards developing and delivering a standard for the operational rating of buildings. This is a non-exhaustive list of the indicators that we are extracting from this model. This is a case study that we have investigated, and we published the results out of that. You see here the physical and the digital model that was developed. That is the files that were used, let's say the backends that was developed in order to achieve this, let's say, post-processing of the measurements. And these are the results that were delivered for different indicators for different buildings using this model. So it's a totally completed and delivered model for the operational rating of buildings with the use of digital twins. Another example of the work carried out has to do with smart energy audits. That is a performance of energy audits with BIM files. This is a study that the first step was already developed and delivered. It focuses on the building shells, all the building materials that we have. From IFC files, we can extract information on the different building elements and components. We do the thermochemical analysis of these components. We introduce weather data. And based on some financial data that we provide, we are able to do the life cycle costing of the building and propose solutions for the energy upgrade of building. So this is the entire procedure of the energy audit, just conducted with the relevant data sets and just with an IFC file. So this, we see here the flow chart of the asset property values extraction of this model that was already finalized, and it's presented as well in energy and buildings, as well as a previous study that was demonstrated. That was as well a study that was finalized in late 23. You also see from the IFC document the attributes that we have used to develop this model, and these are some of the results and the interface that we use to show the results of the smart energy audit, and some other, let's say, graphs which demonstrate the parametric assessment and the performance of the different scenarios that we examine with this solution that we have developed. Okay, so I'm done. These are just some studies that were published.